Good morning, good afternoon, whenever you may be watching this. This is for Pre-Algebra Lesson 8.3. I meant to post this video yesterday, but some things got in the way. I wasn't able to do that, and so I know some of you may have already done the homework for this assignment and this lesson, but I still wanted to post this so you would be able to have the material, have the understanding if you needed to use it. So we're going to go through real quick several of the examples in section 8.3 of the Pre-Algebra book. So if you have that, go ahead and pull it out, and let's go ahead and look at that. Now this section here is applying equations. Basically, it's turning numbers or the word problems into equations that are doable. The question you guys often ask, where are we going to use this in life? Well, this is definitely going to be needed in greater math and just having an understanding of how logically be able to work through math problems, as well as again, just the information you will need to be able to properly use critical thinking on different parts here. So look there, page 323 in your book. It says, first of all, it gives you a word sentence, the statement there. The top above example 1, it says, the sum of 3 times a number and 7 is 1 less than twice the same number. Is in math almost always represents the equal sign. So put that straight in there as soon as you do it so you'll be able to figure out. One of the big things that scares students with this is that there's so many words in there and it's all looking pretty complicated, but it's not. Just break it down one little section at a time. So here it goes. First of all, the sum of 3 times a number and 7. So the sum, we're dealing with addition there. 3 times a number. When it says a number, that's your variable. You put in x, they use n. So 3 times a number, 3x. So, and then it's the sum, you've already put in addition, and 7. So therefore we put in the plus 7. You have your equal sign where the word is, and then the second half of the phrase says 1 less than twice the same number. So 1 less, that means you subtract 1, twice the same number, using the same exact variable, and then it's twice that variable, so it's 2 times it. So 2n minus 1. So your equation comes out to 3n plus 7 equals 2n minus 1. Let's go ahead and look at example 1 on page 323. All right, example 1. I'll show it up here on the board like I normally do while we're in class. So look there, it says find a number such that 5 times the sum of that number and -3 is 3 less than the opposite of the number. Again, that's a lot of words, a lot of information being thrown at you that looks kind of scary, but we just have to break it down. So first of all, we put the equal sign in. That shows us the 2 different sides of the equation we're working with. So you see the word is. All right, I apologize for the glare, can't help much with that, but you guys will be okay. So you go through there and then you work the first part of the equation, the first part of the word statement there. It says find a number such that 5 times the sum of that number and -3. So if it's 5 times the sum of something, that means it's whatever is added together, you multiply that by 5. So therefore it says 5 times the sum, so we have some addition in there. It says 5 times the sum of that number and -3. Well, it says that number, so that's our variable. If it knew what that number was, it would tell us, but it doesn't know, it's an unknown, so therefore it's the variable. So that number and -3. Now, it does say 5 times the sum. Well, what do you have to do in order to make sure you get the sum of the number to multiply it by 5? You put that in parentheses. So the first half of our statement here is 5 times the sum of x and -3. So that's what we have there. Then it is, our equal sign, is 3 less than the opposite of the number. Well, the opposite of a number, first of all, let's start with the 3 less. Let's start from the one side and move there. It's 3 less. We already looked at that from our first part, is -3. So it's 3 less that we have there. Move that just a little so you're able to see better. Didn't really help though, but so it's 3 less. Now, and that is not a plus sign, there's some smudges on the board that makes it look there. Now we look at it and say the opposite of a number. Well, the opposite of a number, if it's just saying a number, so it's So a positive number. So the opposite of that is it's negative. So your term or your equation comes out to 5 times the sum of x and negative 3 is negative x minus 3. All right, then it goes through and tells you to find the number. So it wants to know what is that variable? What does that represent? So basically at the end, x equals what? What does x equal? That's what you're trying to figure out. So let's go ahead and do that. First thing you have to do, and this is math you guys have been doing the whole time, you have to distribute the 5 to both inside the parentheses. 5 times x is 5x plus 5 times negative 3 is negative 15 equals, and then this stays the same, negative x minus 3. And we're going to go ahead and add our opposites so we don't forget that that is a negative 3 over there. Then we need to combine our like terms. It is easier to work with the variables on the left-hand side of the equation. So in order to do that, moving our variable over, here's what we have to do. You have a negative x over here. Well, how do you get rid of a negative number? You add the positive of that number. You add the other one there. So it's a 1x, negative 1x, plus a 1x. So 5x plus 1x. Now we go down to the next section. We have 6x plus a negative 15 equals a negative 3. All right, let me redraw that 15 there. Negative 15. Then what you do is you bring your 15 to the side, get your x by itself as best you can. So you're adding a negative 15, so you add a positive 15. Add a positive 15. So you come up with a positive 12. All right, I'm going to move it over here so now we have 6x equals 12. You have to get the variable by itself. In order to do that, the opposite of multiplication is division. Divide both sides by 6. Divide by 6. Your x comes out as 2. All right? X equals 2. That is example 1. Go ahead and turn the page. I won't have you do the skill check since we're not in class. It's a little bit more difficult to do that. And let's go to section example 2 of section 8.3, page 324. This one is a little bit different. This one here is they're looking at consecutive numbers, and they'll come at you with 2 different types, either consecutive odd or even numbers, and they'll come at you with simply consecutive numbers. Consecutive means one right after the other. 2, 3, 4 are 3 consecutive numbers. 1, 3, 5 are consecutive odd numbers. 2, 4, 6 are consecutive even numbers. All of those are going to come up. I will show you how to solve those. So let's look at example 2. It says the sum of 2 consecutive integers is 173. Find the integers. So let's go ahead and figure out how to do that. All right, clear it off the board. Let's go ahead and look at this again. It says the sum of 2 consecutive integers is 173. Find the integers. Well, we're looking for 2 different pieces of information here because it says 2 consecutive integers. When those are added together, it equals 173. Well, how do we figure that out? Well, I'm glad you asked. I'll show you. So first of all, we have to represent the information we're looking for. So we're going to have x is the smaller of the integers. And then it's a consecutive integer, so therefore, whatever x is, it has to be the next number. Well, how do you get to the next number mathematically? You add 1 to it. So x plus 1 is the larger. Now, if we look back at the statement that they give us, there's a very big clue here. They say the sum of 2 consecutive integers, here are our integers, they are unknown, that's why they're represented by variables. The sum of 2 consecutive integers is 173. So therefore, we have the big information we know is where our equal sign is. It is 173. Okay? Then we simply put that these 2 added together, x plus 1, equals 173. This is very simple to do. So you go through and you add or you combine your like terms. We have 2 x's. So it's 2x plus 1 equals 173. then you just solve it. I forgot my 1. Plus 1 equals 173. So you subtract both sides by 1. So we have 2x equals 172. Then you divide both sides by 2. Divide by 2. X equals 172 divided by 2. They do the math there for you in your book. 86. Now, this is not your final answer because it wants to know what both of the integers is. This is simply telling you what the smaller integer is. In order to find out the larger, you have to add 1. X plus 1 equals 87. These are your answers. You will have 2 answers on these particular equations. You also looked underneath example 2. They show you how to figure out if the statement says consecutive, odd, or even. Well, if you are going from the odd, let's say even consecutives, 2, 4, 6. How do you go from 2 to 4 mathematically? You add 2. If you're going from 1, 3, 5, how do you go from 1 to 3 mathematically? You add 3. Sorry, you add 2. That's what you do there. 2 plus 2 is 4. 1 plus 2 is 3. So that's how you jump the even or the odd consecutives. Now, sometimes it'll tell you 3 consecutive numbers or 3 even consecutive numbers. If that's the case, whoops, I should not have erased that part. But if that's the case, if you have 3 consecutive numbers, well, to find 2 consecutives, you start with your smallest one, x. To find the next one is x plus 1. So to find the third one, is x plus 2. Oh, you can't see it. I made a really good joke there. Let me write it down here. So to find the smaller one is simply the integer you're looking for. To find the larger one is x plus 1. To find the largerest one is x plus 2. Yes, I'm well aware that's not an actual word, but that's okay because you're not here to judge me for it. And so we go through here and able to figure that out. That's how you do it. It's the same way if you're looking for 3 consecutive even numbers or odd numbers. You simply do x, and then your next one is x plus 2, and then the next one would be x plus 4, is how you would do those to figure that out. All right, let's keep moving on to the next one, example 3. Find 3 consecutive odd integers such that 3 times the third is 2 more than 5 times the first. Give me a moment. Let's go ahead and take this out. Now with this one, again, a lot of information, but very simple to do if you do it bit by bit like you know how. There are some of you who are going to panic when you look at this. You know who you are. Don't panic, calm down. I'm not there to help calm you down in the ways that you need to be calmed down. You know, again, you know who you are. Don't panic, all right? Just take it a little by little, piece by piece, figure out what each section of the phrase is talking about, and then simply work it out in that way. So it says find 3 consecutive odd integers. Let's start with that, very simple. How do you figure that out? First of all, you have x is your smallest integer, and they're odd integers, so you have to skip an integer. So then you have x plus 2, and then you have to skip another integer from the first one because it is looking at it as 3 consecutive ones, and which comes out to x plus 4. Those are your terms you're going to be working with there. Then it gets a little bit more exciting. All right, so find 3 consecutive odd integers. We've already written that up here. Such that 3 times the first is 2 more than 5, or sorry, 3 times the third is 2 more than 5 times the first. How does that look? Put your equal sign up there. All right, let's work down here. Have our equal sign. It says such that 3 times the third. Here's the third one. How do we do it with 3 times this type of term? parentheses, 3 times x plus 4 equals or is 2 more than 5 times the first. All right, so you have 5 times the first. This is the first one, so 5 times that. But then they throw something in there, a little bit different. They say 2 more. Well, if you are mooring something, it's addition, you're adding. So you add 2 to that one. Well, Pastor Rogers, you're not doing anything with the second term. What do we do? I'm panicking. Don't worry about that. That is simply there to figure out what the terms are. That is not necessary. That doesn't necessarily have to be part of the equation. It's simply there to help you later on. All right. So let's look at this here. Our equation should look like this: 3 times the quantity x plus 4 equals 5x plus 2. All right, let's go ahead and solve that. You distribute to both sides, or to both terms inside the parentheses. You have 3x plus 12 equals 5x plus 2. Combine like terms onto the same side. Remember, we want to get our variables all on the left because it's easier to work with there. So they do it a little bit differently. They move the variables to the right. It doesn't matter, but it is easier sometimes depending on what you're doing it. Most of the time, it is easier to have your variables on the left-hand side of the equal sign. But if you do that in this particular situation, you're going to be adding steps, and you're also going to be adding in negatives. And I know some of you don't enjoy the negatives as much, so here is what you can do. It'll be the same answer, but you move the variable to this side. If you were to move the variable to this side, you would come out with a negative 2x, which at the end, you have to get rid of that negative 2, and you have to do more steps to do that. If you move the variable to this side, then you have a positive 2x. The answer will be exactly the same, it's just less work. All right, and with math, you want to do it the best way you can, but you also don't want to make it hard on yourself. If you're going to get the correct answer, do it the way that helps you the best. So we subtract both sides with a 3. Take 3 away from this side, take 3 away from this side. That gives us a 12 equals 2x plus 2. All right, that's where we're at there. Now, I'm going to rearrange the board a little bit, and then I'll be right back. All right, I moved my screen down just a little bit so that we can keep going down here, and you still have all of the parts of the equation still up here in case you need it. So we keep moving here. We subtract 2 from both sides, which gives us a 10 equals 2x. And then simply looking at that, able to figure it out, you divide both sides by 2, divided by 2, you have 5 equals x, or x equals 5. Now, remember, that is not our final answer. That is only one of the answers. This equation has 3 answers. If you remember at the top, we had the 3 different terms we were looking for. It was x, and then x plus 2, and x plus 4 is what we would have there. So therefore, how do we figure out what the other 2 terms are? We add these parts here. So x equaled 5, this equals 7, this would equal 9. These are your 3 consecutive odd integers that come through there. Those are your 3 consecutive odd integers. That is your equation, your answer there. All right, we are going to move on to the next section. The examples 4 and 5 and 6. Dealing with those should be pretty simple, simply plugging in information to a formula, and then we will move on. This next part here is the basic equation of figuring out how far, how fast, or how long it takes an object to travel. It is distance equals rate times time. Distance equals rate times time. Now, distance, that's obviously the amount of distance traveled. Miles, kilometers, inches, centimeters, whatever it may be. They have that there. Rate is how much time it took, or sorry, not how much time, but how fast are they going? And then time is how long it took them to get there. And so that's what they were doing there. So what would take place here is we'll figure out what this rate times distance equals rate times time. How do we plug the information? Look at example 4, page 325. If a ship is traveling at 20 knots, which is a nautical mile per hour, how long will it take to travel 55 nautical miles? Now, you don't need to know how fast a knot actually is or where that term came from. That's not important. It still will fit into the equation that you have here. So it says they rearrange it a little. They do rate times time equals distance. It is the same equation. They just did the switching of the equals of the terms on the equal sign there. You'll get the same answer as long as you plug it in properly. So let's see here. The distance that they are wanting to travel is 55 miles. All right. So distance 55. Now, they say it is knots. They traveled at 20 knots, which is miles per hour, nautically speaking, in the ocean. All right, so that is your rate. And then they ask, how long will it take? Obviously, that's talking about time. So how long will it take to go through there? So you have 20. That is your rate, how fast you went. And then time is how long did it take them to travel that. So this, you go through and you know how to do this very simply. Divide both sides by 20, divide by 20. I'm going to rearrange it. The time it would take is roughly 2.75 or 2 hours and 2 hours and 45 minutes is what it would be. 2.7 hours, 2.75 hours. You also, if you're doing a fraction form, it would be 2 3/4 hour. Leave it simply like this if you're doing it. Don't try to calculate in your head that it would be 2 hours and 45 minutes. All right, leave it in this form. That'll be a lot easier in that way with the later parts there. All right, let's go ahead and look at the next two examples. I don't think I need to write them on the board. We can simply just walk through them. You have it there in front of you. Example 5. What is the speed of the wind if a plane capable of flying 400 miles per hour takes 3 hours to travel 1,050 miles into a headwind? That means that when the plane is traveling, the wind is blowing against it, so it's a headwind there. This is pretty easy to figure out. What you have to do is your rate, the speed you are going, is actually hindered by the wind. So how do we figure that out? They go through and they give you all the information. They give you their distance, they give you your rate, and they give you your time, but they throw in the wind. And so they figure that out there. They go through here and they say that, that they're subtracting from it. So look at the example there. R, rate, minus the wind speed times time equals the distance traveled. So we go through there and figure it out. Plug in all your information. 400 miles per hour was your rate. The time was 3 hours, and the distance was 1,050. And so you distribute your 3 to both things inside the parentheses, and then solve the equation through there. Just solve it down as you know how. The wind would have been 50 miles per hour. In other words, they were flying this way at 400 miles per hour, but the wind was pushing against them at 50 miles per hour. Example 6 is the same thing, except instead of being hindered by the wind, this individual is being helped by the current. So the current is actually pushing him faster. Luke and Andrew paddled their canoe 22 miles down the river in 4 hours. If the river's averages 1.5 miles per hour, what is the average rate in still water? In other words, how fast could they paddle if they were paddling on a lake where there were no current to help them? So here they use C. They give that as it, but they don't tell you the rate. They don't tell you how fast they are moving. All right, because that's what you're trying to figure out. So R plus C times let me tell you what is the rate plus the current times the time equals the distance. So now we're trying to figure that out, to plug the information in, and then go through and solve the equation. All right, for this assignment, you have it on your piece of paper there of what you need to do, and so that should be helpful there. If you have any other questions, or if you already did this assignment and you were like, I did it because I had to, but I don't really think I understood it that well, feel free to redo it. I am totally fine with that. That is perfectly okay. It's my fault that this video was not posted earlier, and I apologize for that. I hope you understand this. I will have another video going through with some little details, things like that. I'll possibly have another video there. But for the next assignment, you do have the other assignment on your paper that was given to you on Monday, March 17th. Again, if you have any questions, please feel free to contact me. Have a good time.